I put thousands of hours into vibe coding, everything from Lovable to Cursor to Claude Code and everything in between. From basic voice recording mobile apps all the way through to actual AI systems that I use in real businesses. And through all of those projects, some principles have become 100% non-negotiable for any app that I choose to build. If you don't know me, my name is Sean. I've worked in product-ish roles for startups. I advise a few startups, and I have my own real companies that I deploy these systems into every single day. And my goal on this channel is to bring you those learnings when I experience them. A real boots on the ground perspective of what actually works and happens in real life when you're using these things. So if your goal is to build actual legitimate businesses or apps that work, these are the commandments you absolutely need to live by. So number one, committing changes like your sanity depends on it. Because it does. Look, vibe coding can get out of hand pretty quickly. Like all of a sudden on a dime, the system goes out and does something that completely breaks an important piece of what you had going on. And sometimes it does not revert out of those changes correctly, which means if you do not have a save point, you will be completely screwed. Now, the solution here is creating your own checkpoints, right? Having your own version control system that you have full control over. Now, that may not sound sexy, but it is the single biggest lever you can pull if you really want to succeed, because it gives you a detailed checkpointing system for your app that you can always revert back to and know that things work exactly the way they were at that point in time. Meaning, if the system jacks up your work, no big deal. You can always go back and maybe you lost a few tokens in the process. So there's a few helpful things to start with. First things first, anytime you start work on a new major feature, you want to create a branch for that feature. Now, the command that is going to allow you to do this is this git checkout -b, and then the name of the branch. I like to name my branches if I'm building a feature / whatever the feature name is. And so if I hit enter, this is going to create a new branch called feature / YouTube example in this case. Now, this is great because you can then experiment with anything in your project without worry that it's going to mess up what you had going on in that main core of your app. So let's just say, as an example, I came through here and I wanted to change how this system works. So this is a system that scores the quality of a password or the strength of a password. And let's say that we wanted to make this password check system more robust to force better passwords. Now, once that entire process is done, I can use another command, generate a descriptive git commit message and commit our changes, right? So if I was to push this through and we run the command through, we can see that we have a very descriptive commit message explaining exactly what we did, right? So we implemented a comprehensive password validation system with all of the different things that were done on the front end and the back end. And so I can run this command and commit these changes. And now we have this change committed to history. Now, once we're done with this, we can jump back into our terminal, for example, one command to make sure that everything is there. And then we can push this to its own branch in our GitHub repository. So in this case, YouTube example. So now when I load into GitHub, we can see I have the option to create a pull request. I can go through, I can review all of the code that was generated, and I can merge this into my actual main working branch. Now imagine a scenario where 3 commits earlier, we made some really important bug fix to our system, but now that bug has been reintroduced later on in the app, and we don't remember the exact steps the system went through to fix it. And we get caught in this death loop of trying to fix that problem, and it doesn't know how to fix it this time. Well, now it's not a problem because we can instruct Claude or Cursor to go back and perform a git diff, meaning you can go back in time and look at the state of those files in the 2 different applications and determine what was working before and what it needs to change now. So this one alone is a complete lifesaver. But how do we help avoid the situation altogether where it's even going back and breaking stuff that we had already made a fix for in the first place? Well, that is where our next commandment comes into play, becoming a memory file power user. So most modern coding agents at this point in time have a system for creating memory files that you can reference every single time you make a request to the model. Now, a lot of YouTube videos out there mention that this is a feature that you should use, but it's not really until you're in the weeds on a detailed project that this becomes something that is immediately apparent as a huge value add. So I'll give you an example. In some other videos on my channel, we're in the process of a full 5 to 6 hour multi-part app build. So from idea fully through to complete working project, all in one tutorial. Now, one of the pieces of that build is that I was using a library called GraphQL to make requests from my front end to my back end. Now, the only problem was that as we were building and building and building on top of this system, it kept making this change anytime it wanted to create a new API endpoint where it could not fetch the identity of the user making the request. It could not find the authenticated user. And so it would get stuck in this death loop where it would break a fundamentally working feature inside of the app, not know how to use the function that I already had in place for it to work, and then would just break and break and break and not know how to fix the problem. So let's take a look at what that actually looks like. Inside of my project, I have this file which gets the current user and makes sure they are authenticated. If the user is not authenticated, then it's pretty simple. They can't make the request that they want to make, right? So we're making sure that only an authenticated or authorized user can make that request. So sounds pretty simple. But the issue is that anytime we created a new API endpoint that needed to use this function, it would break and it wouldn't know how to use the function. So first it would start off with, hey, the app isn't actually building properly and I can't use it. Then I would go into Claude Code or Cursor and try to actually debug what was going on. And the solution wasn't to fix the bug, it was to fundamentally change the function and how it worked, which would break every other piece of my app. And that was becoming a huge pain in the ass, and it was losing me hours in my process. So the solution was to fix that by adding in a memory about how to handle GraphQL requests in the future. Now, there's a few things I added in here that specifically helped. Number one, anytime the front end makes a request to the back end, check if there's already an existing query to do that. Number two, anytime we are making a request, make sure that the front end is mutating properly and it matches what the back end is expecting to see. And number three, the one that really did it, anytime you start building a new endpoint, you absolutely must reference similar endpoints to understand the patterns that already work inside the app. The moment I added this into this memory file, that bug ceased to be. It never made that mistake again. And so this is huge because, again, the moment I added that into the file, I never ran into that issue again. And so it maybe takes you 3 or 4 minutes to update that file, but it saves you 3 or 4 hours in lost back and forth, bash your head against a wall bugs with Claude Code or with Cursor. I was spending hours debugging this stupid authentication stuff when what I wanted to be doing was building all of the cool features of the app that the user is going to actually see and interact with. But this actually leads me to the next commandment, which is one of the most important ones, because I had to be aware of the fact that that was happening in the first place. So commandment number 3 is building intuition around when you need to actually sit there and look at the stream of thought coming out of your coding tool. Because here's the thing, vibe coding does not equal mindlessness and just accepting anything that pops out of the system. You should build a habit of thinking like an orchestrator, because knowing what you are building is what will take you to the next level and allow you to outperform 99% of the other vibe coders out there. I view vibe coding as one of the next great learning evolutions, because if you're paying attention, you don't just avoid these one-off problems like the one I'm about to show you, but you start building knowledge and context around how to actually build these things. What does it mean to build a robust solution to something that is going to operate in the real world? So if we go back to this example of creating this password security system update, I think what a lot of people are going to do is just see this output about everything that changed and say, okay, cool, on to the next chat, right? And you're away from that thing immediately. You don't go through and commit the change. You're just, hey, I'm on to the next thing. But what you really need to do is build a habit for thinking about and reading the actual outputs of these things. They'll take you a few extra minutes in your process, but you're going to start to build a real understanding, and you're also going to catch things that it does that you don't want it to do. Now, this is one of the reasons that I actually, for example, like sometimes using Claude Code with Cursor, because I can come back into Cursor, turn off the super advanced models, and I can just ask it to explain pieces of this to me like I'm a 5th grader, right? So I could say, explain to me how the entropy-based scoring actually works. And now it's going to use a cost-efficient model to actually explain this concept to me, right? It's going to read the file, and it's going to show me or demonstrate to me how this entropy-based scoring actually functions. So again, in the real-world context, in that get current user function that I showed you, I was reading the outputs from Claude Code, and I noticed that every single time it went through and said that it needed to modify that file, which was already working, anytime it modified that function for what it thought it needed to do, the entire app's authentication would break. I would get booted out all of the screens that I was in. I'd have to flush everything out of the system and revert the change. It was a total pain in the ass. But the only reason that I caught that was specifically what kept breaking my app is that I was actually reading the outputs from the system, right? I was reading the chain of thought of what it was saying was breaking, noticing what file or what function it kept trying to change, and then telling it, don't change that anymore. You're doing me dirty. This is actually another reason why Claude Code's planning mode, or any model's planning mode, is a huge level up also to use, because it allows you to catch certain things like that before it even gets implemented in the first place. So if you genuinely want to become great at this stuff, you absolutely have to start doing this. It really is a non-negotiable, because it not only helps you in that moment, but it helps you build contingency workflows, automations, and systems to continuously get better and better and better. That's part of the reason that the next commandment up is self-documenting loops. So one of the worst things that you can do in your project is to build something that you do not know what it is or how it works or all of the files that are actually involved with that feature working. Because here's the thing with these tools that you will realize when you use them enough. It's not uncommon for them to build features but not actually hook up all of the advanced functionality that it made for those features. So it will sometimes build something advanced, but fall short or take shortcuts on actually implementing it. So I'll give you an example. I had a situation last week where I built this kind of complicated feature that was supposed to go out and do all of these cool things, right? It had a bunch of different vector databases with user data stored in them. And before it went out and made the request to OpenAI, it was supposed to retrieve all of the relevant vectors from the database and send the results through in the response to OpenAI. Now, what the system did was it went and it built out all of those endpoints, and the functionality was there. It could embed things in the vector database. It could retrieve things from the vector database, but it never hooked in the part of the tool that was meant to infuse that data into the requests that got made to the OpenAI service. And the only reason I caught this is because I asked the system to document all of the files that were used in that feature, what it created, and where they hooked together. And it basically told me in that feature documentation, hey, yeah, we built all these other things too, but they're actually not hooked in yet. Do you want me to hook those in for you right now? So this one has a simple mode and an advanced mode that you can implement. If you're in a tool like Cursor, you can simply come through here and give it that instruction. So you can say, look through the user onboarding feature and document how it works. The level of detail should be similar to that found in this file where I had already done it with Claude Code. And I can say go. And now it's going to go out and it's going to build the feature documentation around that onboarding feature. Now, if you're in a tool like Claude Code, for example, you can maybe use hooks, or you could use a customized agent that's sole purpose is to go through and document features after a new feature is built. And you can actually configure it to invoke that thing manually so that the moment it finishes a new feature, it goes through and it documents how the feature works. Either way, whether it's the basic mode or the advanced mode, it's something you should be doing. Let's take a look at what this file looks like. So inside of this project, I was working on this branch where I was building out an AI chat feature. So it would store like user conversation history and knowledge about the app. So it's a recipe app. So it would store like recipe information into this vector database. And then when a user asks a question about a recipe they've made or a recipe they want to make, it can use that vector database to do stuff. And so I had it go through and build out this feature. And we can see that it went through and it documented pretty much everything. So it built the core AI chat service architecture. It built out the real-time chat interface. It built out all the database models. It built out the API layer. And then it will go file by file and tell us exactly what it did. So here are all the files that were created new. Here are all the ones that were modified. For each service that we have, the key capabilities of it, what it can do, what it can't do. It'll even show you the different commits on this branch that are related to it and what we did in each commit. all the different files that were created, again, summaries, and what the integration points are of those different features where they are actually working with the system. And now you can have it include a section in here, which the old version did, which says like what has not yet been actually hooked up yet. What did we intend to build that's meant to be in the app that's not actually hooked into the service it was intended for yet. So now we can see we got a similar level of documentation for our user onboarding flow, okay? Now this is a different model. This is using GPT-5 because I thought, why not just use that right now? It's obviously not as much in depth, but hey, this isn't a video about the shortcomings of GPT-5. Again, this is one of those things where you need to realize that these tools can build so fast, they can outpace your ability to understand and retain what is being built, right? If you're actually a software engineer that was in there creating all of these files and all of these functions by hand, you're going to remember the different parts of the code base, where the files live, what they connect to, because you were there, right? You did it. If we're not doing that, we need to make sure we have backup systems in place to help us retain the different things we're building, why we built them, and how they function. So this helps us make sure that we're not building steamy piles of shit that don't actually work the way we wanted it to. But speaking of steamy piles of shit, the next commandment is realizing that a lot of the time, these models are in fact shit-making machines. So when your context gets big, your project gets big, these tools will often go off the rails. And so it's often easier to actually just start over on a new task. So how do you do that? Well, this is why committing your code is so important to do, because we can just revert back to an earlier commit. So one helpful command that we can run here is git log -- one line. And what this is going to do is it's going to show you a history of commits across this entire project. And so what we see over here are the actual like IDs for those commits. And so we can see right now we're here at the head, right? We're at like the most recent part of our commit history. And we can see that, oh no, we broke it, right? We broke our app, and we want to actually go back to the point in time where this thing actually worked. And so all we need to do is copy that ID. We can pop back in here and then just do git checkout, paste in that ID. And now we have switched back to the point in time where this thing actually was. And so if we go look at the project, we can see that that other second feature documentation that was right below here that we made right here, it's not actually there anymore, because now we are at the point in time on this app when it worked at whatever we had committed at that point in time. So everything else we did afterwards and the other commits we made and the files we changed and all of that, just not there anymore, right? So we're back in time to a point where it worked. So don't waste time, tokens, and sanity when you could just revert back to a state in time where things weren't utterly broken. So commandment number 6 is, in my opinion, an absolute non-negotiable for vibe coders, especially if you do not come from the world of software engineering. And that is adopting a 3-loop planning cycle before you ever write a line of code. So a lot of vibe coding starts with a very simple idea. Like you're going throughout the course of your day-to-day life, you stumble upon some thought or some idea, and you're like, man, I could build an app for this. Other people would surely pay for it if I would pay for it. Now that's awesome. That's where a lot of great things begin. But that is not enough context to actually build something. So we want to flesh out our context as best as possible so that the system can take the plan and actually do something with it that matches our expectation of what we wanted in the first place. So I have an entire video on my 5 non-negotiable prompts that every vibe coder should use. I will link it somewhere around this video. So right now, I want to show you the first 3 prompts because they are specifically my planning prompts. So I use these as Claude Code agents, but you can use these also as prompts. They also work very well just as prompts in any system. So prompt number 1 is our product manager, and this is the one you want to start with. This is where we're taking that raw idea that you have for something, and we're turning it into like a structured plan. What are the different types of user personas that might actually use this thing? How are they going to use it, right? How do they interact with the app? And what are we putting in the MVP versus what is going in the feature backlog, right? So we need to have a really clear understanding out of the gate of what specifically are we going to build, because this is going to get funneled into our next prompt. Now, again, I've done entire videos on these, so I'm not going to go super far in depth into this, but it's really a brainstorming exercise where we want to build an executive summary, like an elevator pitch of what this thing actually is and the core problem that it's actually going to solve for people. after we've done that, we want to build all of those user stories or like those ideas for the features that we have into concrete feature specifications. I don't want to just take my idea of, hey, it's a recipe app that people can use AI with, and then just go throw that into Lovable and let it go build something, right? I'm not going to get anything out of it because it doesn't know what I wanted in the first place. And so in this product manager exercise, we are fleshing out what exactly am I going to build. And so we go through each feature. So depending on the scope of your MVP, you could have 3 things here, you could have 10 things here. But we're going to go through what is the feature, what is the primary user story, right? As a blank, I want to blank so that I can blank. What is the acceptance criteria? How do we know when that feature is done? Like when the user is experiencing that like end complete state and it worked? What are the different dependencies with other features that it might have? And then any like core interaction points for the user. Okay. Then we document the functional requirements, the non-functional requirements, the main components of the user experience requirements that need to be there. And then we ask ourselves questions, right? We want to make sure that we are really clear on what we are building. And so if we just went to look at this one very quickly for the app that, again, I'm doing a very long form, like 6-hour video on my channel, this is where it started. It started with this prompt where we go through and we go from, hey, I have this idea for an app that can take a restaurant photo and turn it into a home-cooked meal. And as we start moving through this, we can see it starts getting very detailed. Who are the primary user personas? And then for each of those, how do they actually move through our application? For example, if I'm doing a photo upload and capture, what needs to be there for this feature to actually be implemented successfully? What are the different dependencies that I'm already going to be aware of? What are the UX considerations? What are the technical constraints that we might have, like the size of the image upload, right? And so we're going through every single feature that is involved in this, and we're making sure it's super well fleshed out. We then repeat that same fundamental premise for our other 2 agents. So the one is the UX UI engineer, where again, we're going through and we are codifying how do we actually build a beautiful user experience? What are the core principles? And then we go through, create a color palette, and for every single feature that we have in our app, we're going to design that feature ahead of time, right? We're going to think about what needs to be in there based on these user journeys that we've built out. Knowing how someone needs to interact with this, what are the primary considerations for every single screen that a user is going to interact with? Now, once we have both of those, we can build out a system architect, which is going to take our product requirements, and now it knows what the actual user workflows are going to be, and it is going to go through and build out an entire technical architecture document for this app. And again, we get a pretty robust output here where we're talking about everything, right? System overview, the dependencies we have, the component architecture, APIs, database, security, infrastructure, performance, monitoring, error handling. We go in depth and we build out everything that is going to be in here, how it interacts, high-level data models, tables, all of that type of stuff is going to be documented before we send this to an agent to do any coding whatsoever. Because then there's no ambiguity. If I pass this to a back-end engineer agent, it knows exactly what it needs to go build because it knows exactly every single feature, the data models, the endpoints, how it's going to interact, what it needs to return back, and same thing for the front-end engineer. It's not going to just divine what the features should be. It's going to actually pull those features through from the outputs of the UX engineer and the knowledge of what the back-end endpoints are. So those first 3 pieces of that loop, the product manager, the UX engineer, and the system architect, are pretty much non-negotiables. So I don't care if you're using Lovable or you're using a future iteration of Claude Code 99, you should be implementing a planning process. And in my opinion, these 3 stages specifically set a really strong foundation for you to succeed. So these commandments are what separates the tinkerers from people that can actually build real stuff with these tools. So my challenge to you is to pick 1, 2, 3 of these things and actually implement them in your workflows this week and see how they impact your process. Because the truth is, vibe coding without a process is just a good way to create some broken stuff that you wish worked. So master these fundamentals now so that you can be in the top 1% of people that are building really cool solutions to real concrete problems. So which commandment hit you hardest? Let me know in the comments below. I actually love to read the comments, and it often is fuel for future video ideas. So let me know. But that is it for this video. I will see you in the next one.